Hello and welcome to this course on Docker. So as the title suggests, we will be starting from zero, assuming no Docker or container knowledge, and then progressing through to feeling very comfortable using Docker for a wide variety of use cases, understanding how containers, images, and image registries work, building our own images, working with multiple containers, and much, much more. So my name is Dan Clark. I'm a Microsoft MVP, developer and consultant, podcast host, user group organizer, and a content creator. I've personally worked with Docker for many years, and I've also mentored and trained teams of developers with how to use Docker, which means that I've seen a lot of common problems that people tend to get hung up on and confused about, things we will definitely cover and tackle throughout this course. So the plan is we will focus on getting you up and running in Docker very early on and getting you familiar with the core concepts, because the best way to learn is to play and do. So whilst I could start off with a whole bunch of theory about how containers work and C groups and namespaces and Linux kernels, you really just don't need to know that stuff to use Docker. Later on in the course, we will dig a bit deeper into those things, but I'd rather you feel comfortable using and playing around with Docker first. And I, for one, am very excited about this journey we're about to embark on. Docker is such great fun and one of those fundamental technologies that has so many different use cases that you just might not initially think about. Then over time, you start to have more aha moments where, oh, I've got this requirement. Aha, I can leverage Docker for that. So let's dig in and see what you're going to learn in this course. So as I mentioned in the previous section, we're going to get you up and running with Docker as soon as possible so you can start learning by doing, which naturally means the first priority will be installing Docker. If you're already set up with Docker, then just feel totally free to skip that section. Then we're going to cover some core concepts: containers, images, image registries. Then we'll show how to interact with Docker using both the CLI and the Docker Desktop GUI. As part of that, we will do a lot of playing around, just spinning up third-party containers and having a bit of fun. And since this course is for developers, it's important to know how to build your own images. So we're going to create a basic .NET web application consisting of a web front-end, back-end API, and a database. Don't worry if you're not a .NET developer, the same principles apply regardless of your chosen programming language or framework, which is one of the beauties of Docker after all. Note that I said web framework, backend API, and database there. So that'll be 3 containers. So we're going to use something called Docker Compose to spin up those 3 containers with a single command and have a setup nice and source controlled. So your colleagues can spin up the same setup with a single command. So imagine you're a developer at a company, or a new developer at a company, I should say, you do a git clone of their project, install Docker, and run a single command, and boom, you have all their entire architecture running and just usable locally straight away. At that point, I'm kind of aware that you will have consumed a ton of information in this course by now, and just starting to get your head around how this all fits together. So we're going to have a small break from me throwing even more information at you, and we're going to look at some different use cases showing different ways that you can apply your newly found Docker knowledge, including in your CI/CD pipelines, helping with your integration tests, and more. And then I'm afraid we are going to dig a bit deeper, looking at how we can manage storage using volumes. We will touch on Docker networking, although given this course is for developers, we won't go too deep there and just focus on what you need to know as a developer. We'll also touch on how containers work with regards to control groups and namespaces. Again, you don't need to know this too deeply, so we'll just cover the concepts. And lastly, we'll talk a little bit about container orchestration platforms like Kubernetes. This will just be a summary though, as this course will not cover hosting containers in production, which is the job of a container orchestration platform. It's just too big of a topic to cover as part of this course. But do keep an eye on DomeTrain for a follow-up course on Kubernetes though. And the stuff you learn here about Docker regarding what containers are and also building images is certainly a very important prerequisite for running those containers in something like Kubernetes. So who is this course for? As the title implies, this is Docker for developers, which means it's expected that you have some knowledge of software development. We're going to be doing stuff on the command line, Without explaining what the command line actually is, we're going to be creating a web app, a web API, and using a database. And whilst it's totally not expected that you know .NET, which is what I'll be doing it in, you do need to know what a web app is, what an API is, etc. Other terms like logging, debugging, source control will also be used throughout this course, assuming you already know what those things are. And lastly, before jumping into the course itself, it's worth noting that any code I write, the web app, the API, Docker files, Docker Compose files, they will be available to download as a zip file throughout this course. So with that, let's get started and jump into the exciting world of Docker. So first up, we're going to install Docker on Windows. So if you go to docker.com, straight away it says download Docker Desktop, and it's detected my operating system Windows. If you're on the Mac, it'll do the same. If you're on Linux, it'll do the same. Now there's Docker Desktop and there's Docker Engine. The easiest way to install Docker is Docker Desktop, but there is a license. If we scroll right down to the bottom here, and then go to Docker Personal, then we can see here it says Docker Personal is a great place to start for personal use, educational, open source, small businesses and startups. So it's worth pointing out that even if you're working for a business, if you're a small business, you can still use it for free. There's an asterisk there. So if we actually go back down to the bottom of the page again, then we can see here right at the bottom, I'm not going to read out all this, but the key point is that if you're a company of more than 250 employees, or more than $10 million in annual revenue, then you need a paid for license, otherwise you don't. And that's Docker Desktop, not Docker Engine. For all of the stuff we talk about in this course, you can get away with just using Docker Engine. That comes with the Docker CLI. You can install Docker Compose. Docker Desktop's just the easiest way to do it, so that's what we're going to use here. So if we scroll right back to the top of the page and go to the home page, and we're going to click on that download button. Now, for the sake of time, I've sped up this recording a bit, so this is going to download it really quickly and look like I've got a super fast internet connection. I don't. And then if we open it up, now the very first page we get gives you an option to use WSL2 instead of Hyper-V. This is for virtualization. It's recommended to use WSL2 as it mentions here, so that's what we're going to use. So WSL2 is Windows Subsystem for Linux, and that's Linux in Windows. It's really, really good. It's a full Linux distro, and Windows can integrate quite heavily with it. That's out of context of this course though, but basically make sure you've got that selected. If you don't already have it installed, then if you go to the Start menu, type Features, choose Turn Windows Features on or off, and you get this pop-up, and just make sure this is selected. If it wasn't selected and you select it, when you press OK, you might have to reboot, and then we're good to go. So click on OK. Again, I've sped this up for the sake of time. If you're following along, obviously pause it. And then we're good to go. So if we click on OK, now we can go over to a command line just to test it's working, and the documentation gives this example. We will go through what this means later when we start talking about Docker images and containers. But if we run this, then intentionally it's going to fail here. If you ever see this error message, and you might see it quite often, it just means that you've forgotten to actually launch Docker. So if we do this and go to the Start menu, type Docker Desktop, then this is going to launch Docker Desktop. So it'll take a few seconds to start. This GUI will go over a bit more later when we talk about the Docker Desktop GUI, but now at the bottom left we can see we've got green. So if we go back to our terminal, run that command again, then we get a nice output. So what this has done, it's downloaded an image from Docker Hub, which we'll talk about later. It's created a container from that image, and this is the output from that container. So we know it's successfully set up and working. So you will need to have hardware virtualization enabled to use Docker, and that's going to be different depending on what your hardware is. It's likely that you've already got it enabled, but if when installing Docker Desktop it tells you haven't, then you're going to have to look up on your manufacturer's website to find out how to do it. So my machine, I've got an Aorus motherboard, and when I'm booting up, if I press delete, then it takes me to my BIOS, which looks like this. As I say, this is going to look different for everyone, but the point I want to make here is that it's not always obvious. So for example, here, for me to enable hardware virtualization, I've got to go down to the advanced CPU settings, and then I've got to choose SVM mode. It just screams out hardware virtualization, doesn't it? Enable that, and that is hardware virtualization. So obviously I'm going to go out and exit without saving because I already had it enabled, but that's how I do it on my machine. It will be different, so you need to look up your hardware. So we now have Docker installed and we are ready to go. And I know you're probably itching to get your hands dirty and start spinning up containers. But first, let's quickly cover a few core concepts, like what are containers? What are images? What are image registries? And also, what would you use them for? This is a course for developers. So how can you leverage containers to help you out as a developer? The easiest way to explain containers is to compare them with virtual machines. They're certainly not the same thing, and they have very different use cases, but comparing the two is a very good way to start off visualizing containers. So in this diagram, I've intentionally kept it simple and left out things like hypervisors and the Docker engine. On the left, we have an example of a physical machine that has a host operating system, so that could be Windows, Linux, Mac. And we've got two virtual machines. Now, you wouldn't want to be running lots of different virtual machines, as you probably know. If you have more than two or even two, it's probably using a lot of your resources. And in the VM, you've probably got lots of different applications running. So you've got a full operating system running inside it, lots of different apps. You generally want some kind of RDP-like session with a GUI to interact with. Now over on the right, we have a similar diagram, but this time showing containers. Now where a VM is virtualized hardware, it's better to think of a container as a virtualized OS, operating system. It shares the host kernel and is a lot more lightweight. You can spin up containers very, very, very quickly. Note that each container in this diagram has just one app. So from a use case point of view, this is one of the ways that containers differ from VMs. A container is typically there just to run one thing, like your API or a console app or a single piece of software like Redis. You wouldn't have multiple things like this running in the same container. In this diagram, I have 6 containers, but you can have way more than that. You can spin them up in seconds, tear them down in seconds, delete them, and we will definitely go through showing all that very soon. And even though they're not a full-blown OS, they still have their own little virtualized file system, their own little network stack. You can even open a shell in a container and run CLI commands. Another core difference is that you generally don't interact with containers in the same way as with a VM. With a VM, you'll probably get a desktop and use it just like you would use your main operating system. Containers, though, are generally used in a much more immutable fashion, where you can use them to run something. You don't tend to interact with containers, even though, as I say, you can totally get a shell in a container. You probably won't do that often. You'll typically spin up your container and access it from your host machine via port numbers. Again, we'll be showing that very shortly. Let's look from an application developer point of view, a few things that you might see inside a container. So typically, as I say, you'll have one primary process, and this could be your app. By your app, if your app has got multiple services, multiple APIs, a front end, for example, each of those things will be separate containers, or it could be a third-party app like SQL Server or RabbitMQ. Your application probably depends on some form of runtime. So if it's a .NET application, the .NET runtime. If it's a Node application, Node. If it's a Java application, the JVM. And it will also package up lots of dependencies, or NuGet packages or NPM packages, DLLs, etc. You might also have local configuration files, so that could be in your container, and environment variables too. And these things are all packaged up together, so you don't need them on the host machine running the container. I can run a Java app in a container on my machine without requiring the JVM installed on my machine, as it's all inside the container. This is just a quick overview though. We'll soon see this in action in the next few sections. And when you see them in action, all of this should soon click into place.